Hello, everyone. Welcome to this webinar on modern C, C++ for DevOps workflow. Thank you for joining us. Just before we start, a few formalities. Please remember to ask all your questions in the Q&A box, and we'll be happy to answer them at the end of the session. Now it's my pleasure to introduce to you my colleague, Hamza, who will present you this webinar. Hamza?
Yeah, thanks a lot, Nera. So my name is Hamza. I'm solution engineer at JFrog, and I'm here today with you to see exactly how we can make your C++ build processes going faster using Conan as a package manager for those libraries. We're also going to see some examples of CI/CD, modern CI/CD processes involving C++ libraries, but managed with Conan as a package, this package manager. And then we also leave some time at the end to answer your questions. But let's start from the beginning and see exactly what kind of problems C++ developers usually have. And it's quite a paradox because those libraries, those C++ libraries are based on one of the most mature languages out there that gives very high machine performance and perform very fast calculation, faster than any other languages of the industry. And that's one of the reasons to be involved in a lot of high-tech devices related, for example, to voice recognition, to self-driving cars, to astronomical calculation. So a lot of very modern and very cool stuff. But in terms of build processes, in terms of CI, when it comes to building those C++ libraries, it has always been like this, okay? Like, a very archaic, very old-fashioned building approach that hasn't changed, for many years. It has been a very quite a pain in the ass, for C++ developers, with long compilation time, a nightmare to manage, all those libraries, to compile them in different kind of platforms and so on. Okay, and this is exactly for that reason that Conan was invented, is to provide you with a solution to go faster. And like any other package managers, it's more or less the same logic. Okay, so the idea is to build once your libraries and to use them many times, to reuse them, and for that, okay, you will speed up your build processes by having those libraries somewhere in some repositories and fetching them out whenever you need them. It would also avoid you to recompile the same libraries over and over again with a very high risk to compile first those components on the wrong platform, and that will in fact compromise your production environment at the end. Those packages, especially with Conan, here we are talking about, binaries, and those binaries, of course, shouldn't be stored in the source control. So we need, in fact, to have some kind of local repositories to host those packages and to manage their lifecycle. The main challenge and every C++ developers know about that, is that it's about managing huge project involving millions of lines of code with, of course, very slow builds at the end, because everything is usually rebuilt from scratch from the entire source code of your application. But here, in terms of package management, we need, in fact, to manage, all those dependencies, transitive dependencies, to manage the compatibility across, different platforms, because, those libraries are really tied to the platform, to the OS they were created for. They are also tied to the build system, depending if you are using CMake, Visual Studio, So we need, in fact, to find a way to have a true cross-platform process that will be able to work with any build system. Okay, so in terms of dependencies, we have, for example, an application that has a library. This library relies and requires the POCO library that in turn requires the OpenSSL library. And this is exactly in that situation that things get a little bit complicated, is that, this OpenSSL library will, depending on the platform where the compilation will be done, it will either depend on zlib on a Linux machine or on some other libraries if we are compiling our software, if we are building our software in a Windows environment. So a few words about, this Conan package manager. So first, it's fully portable. It can run on any kind of environment and architecture. It's a full open source tool distributed under MIT license. You can check out the source code if you want. You can contribute. And in terms of architecture, it has been designed around a client-server architecture concept, meaning that you can fetch packages from different remote servers, exactly the way that you could do, with your source code, managed with Git. Regarding the client itself, the client is here, in fact, to manage the logic for package creation and consumption. Okay, so in Conan, we have this concept of package metadata managed, through quite simple Python scripts. And in those Python scripts, you just describe what dependencies are linked to your binary based on the source code, and define also the different stages because, to run and to compile your libraries, instead of directly interacting with the build system, Conan will be like an abstract layer on top of it, and will get some information about those package metadata to see exactly what type of library should be fetched out of the binary repository manager, and what open source libraries are going to be used. So we have this client, and then the server would be hosting the binaries, and it can live under various forms. So by default, Conan will be shipped with a Conan server to host that can be used to host those binaries. But you can also use Artifact 2. We've got community edition for that to provide you with some CC++ and Conan repositories. You can also use Bintray if the end goal for you is to make your packages available on the cloud for public or private distribution, whatever you want. Okay, so there are basically different options for that. Conan Center. So Conan Center is one of the major CC++ public repositories that you can contribute to if you want. And it's like JCenter for use for open source Maven library. So let's jump into a demo right now. Okay. So see. Okay, so we are simply going, in fact, the first example that I'm going to show you is just to compile a very simple program, but at the same time to use some precompiled existing Conan packages. So basically, this program is not going to be built, from scratch. We are going, in fact, to reuse some existing Conan packages. So for that, I'm going, in fact, to use this simple example. So if you want, to replay this demo, you can just go to the official Conan documentation, and you will be able to find, everything will be described the right way. Okay, so let's fetch out this program. Okay. So let me describe, all the elements. So first, we have, okay, so it's a very simple piece of code. Okay, so here we are going, in fact, to rely on the POCO library for calculating just the MD5 of a string. But since here we depend on the POCO library, okay, what I need to do here is not to compile everything, but to get this POCO library from somewhere. So for that, inside my project, I have this Conan file, and in this Conan file, two simple things. Okay, so first the requirements. So here my project relies and depends on this POCO library, and I'm going to use the CMake generator in order to build this library. This is exactly from this file that Conan is going to be aware of the libraries that I will need to build my software. Apart from that, we have our CMake list text file. Okay, so basically this configuration file, just a CMake configuration file. We are going, in fact, to have some additional things to basically connect Conan to my CMake build system. Okay, so here I have my CMake minimum version required, and I'm going, in fact, to include a Conan build info CMake and to initialize, the basic configuration of my Conan environment. So now, one thing to do is to install my Conan packages. Conan install. Let me check something. No, I'm not going to do it from here. Yeah, so now it's time to jump into a demo. Okay, so for that, I'm going to use a very simple example to build, some piece of code based on some existing precompiled libraries. Okay, so for that, I'm going to just fetch some source code from this Conan community GitHub repo. Okay, and so first let me remove this. Okay, and okay, so we have this project, sorry. Okay, so let me describe what we have here. First, we have a very simple program, okay, and that relies on the POCO library for calculating the MD5 of a string. Okay, so but in order to build this component, I'm not going to compile everything from scratch. I'm going to use an existing POCO library that is going to be provided by Conan Center. In terms of in order now to define what dependencies I will need. Okay, everything would have to be described here in this text file. Okay, so this project requires this POCO library, and I'm going, in fact, to use my CMake generator. What else? We have the CMake file list. Okay, so here we are going, as you can see, we are going to have some specific include related to the Conan build info CMake, then that will be used then afterwards by my CMake generator. So let's try to build, sorry, first need to create my, okay. Now let's try to first fetch out the library that I need to build my component. So here we can see that, okay, my component was not found in my local cache, and here my Conan client connected to my Conan server try to get my package from the official Conan center. But what I see that we have also some other libraries. So we have OpenSSL, we have zlib. Okay, let's see what we've got. Okay, yeah, indeed we have now 3 libraries. Okay, so it's just now that I see that Conan automatically retrieve, those transitive dependencies. And if I want, I can eventually get some more information about my package. So here, for example, let me see Conan info. And here I can see basically the whole map. Okay, so my POCO library requires OpenSSL. And my zlib is required by OpenSSL. Okay, same. And my OpenSSL is required by my POCO and my zlib. Okay, so here we have 3 different libraries depending on each other. But what if we have hundreds or thousands of libraries in a project? How could I get the global map? So there's something very simple, is to use basically the same command as previously, Conan info. Okay, and here very simply just to build an HTML file that will graph. Let's see, graph. Okay, so let's see what we've got here. Okay, so simple HTTP server, webinar, and now let's go there. Okay, so here basically you can see, you can visually check this component graph. So by seeing what are the libraries required directly by your project, and then to see one by one all the transitive dependencies. So quite useful indeed. Let's quickly go back to our environment. Okay, and now let's try to build my project. Okay, so here, by the way, you can also get some more information by searching one particular library if you want. Okay, so I can, select this one. Okay, and get more information about all the settings, like the compiler, the build type, the architecture, and so on. And see also, by the way, also all the required. Let's try to build this application. Okay, so here I'm going to run my CMake. Build type. Okay, and now let's finish that. Sorry. And here I should be able to find basically my MD5. Okay, library. So everything now is okay, but I haven't finished here because as we saw previously, the zlib, the OpenSSL, and the POCO libraries were retrieved from the Conan Center, which is, a public repository. But what if I need, in fact, so that's not the best option if I want to speed up my build processes. Because if I need to retrieve hundreds or thousands of libraries each time that I'm running a build process, so first I'm not going to consume, all this bandwidth, and also to depend on the public repository. So I need, in fact, to host my packages somewhere. So here I'm going simply to upload them into a local repository. And I'm going for that to use Artifacto. Okay, so if you're interested, you can, download the community edition of it. Otherwise, here, this one is the professional version, which is, universal, supporting, not only Conan, but, various package types. This is, one of the main advantages of the Pro edition. But I'm going, in fact, to publish those packages into this Conan webinar local repository. But for that, I need to configure my Conan client. So let's see what are the endpoints, okay, connected to my Conan client. Okay, so I have my Conan Center. In order to push my cache packages into Artifactory, into that local repository, I first need, in fact, to add it to my client configuration. Okay, so for that, I can simply use the Set Me Up button. Sorry. Oh, okay. Sorry for that. I need to reload myself. Let's see. And okay, it's better now. Okay, so Set Me Up button again. Okay, just need to basically run this command, Conan remote add, then just give a label, and then the URL to this local repository. Okay, so let's do it this way. I'm just going to copy this URL, because this is, the most important. Okay, and here I'm just going, in fact, to add my Conan remote add. I'm going to name it my Artifactory. Okay, and just give the URL. So now, if I just look at my remote list, okay, now I have my Conan Center and my Artifactory, which is, in fact, is not the best situation, because it means that if I need to get any package when running a Conan install, the package will be first retrieved from Conan Center, and if it's not in Conan Center, it will my Conan will then check my local repository, which is not exactly the right logic, because I should always look first in my local environment, my own ecosystem, before getting the package from the outside, if I don't have it locally. Okay, so for that, I'm going to just correct that thing, okay, by removing this my Artifactory, okay, and to add it remote, and then to add it this time to the first position. Remote list. Now it's much better because I have it in the first position. It will be the first resolution endpoint. Now let's try to upload my packages into into Artifacto. Okay, so I'm just going in fact to upload. Okay, can I say all? And then I'm going just to specify the remote, which is my art. Yeah, so here you have a confirmation. If you don't want to bother yourself, with those confirmations, especially if you have, tons of packages to upload, okay, can just confirm, okay, and those packages then will be sent to Artifacto. Okay, so the upload is being processed. Thing going on. Okay, and now if I quickly go back to Artifactory, I should be able, in fact, to see those packages hosted in this local repository. Okay, so you have, for any type of package in Artifactory, there's a default metadata calculation. Okay, where you can see the name of the package, the version, user, and so on. And you can either, if you want, even if you want, you can add some properties, okay, just to reflect the maturity. Even if the maturity itself is usually a part of the package description, okay, and the package terminology. Because a package, a Conan package, is usually the library, okay, the name of the library, the version, then the owner, and then the maturity. So it could be testing, it could be stable, whatever you want. It's just a channel, okay, if you will. Okay, so now that I have those libraries in Artifactory, if I have any other processes consuming those libraries, the easiest way is just to, for that process to have its client configure, not to be directly connected to Conan Center, but to be connected to Conan Center, but in the second position. So the first provider, the main source of truth, should be not my local cache, because the cache is always ephemeral, but more Artifacto. Okay, so so now we are going, in fact, to have a look at a second example, is how, in fact, to create a Conan package. So for that, I'm going to create just a folder, say my package. Okay, and to create, to initialize a new version of my Conan package. I'm going to just run Conan new, and I will name it, for example, my package, and just give it a version. Okay, so this operation just created a Conan file for me that I have here. Okay, so in this, this is basically a Conan recipe. So this is exactly that file that determines, all the parameters and all the metadata related to my package. So I have the package name, package version. This is exactly where I would put the license, the author, the URL of my Git repository, the description, the topics, and the settings. So here, those settings are really important, because this is exactly what will determine the package binary that will be associated with the global package. Because, a Conan, and I'm going to show you that, a Conan package is, I would say, a wrapper, okay? And underneath, within this Conan package, I can have like different sub-binaries, and each binary will reflect the precompiled library of that package that was built on a specific platform for one OS, for one compiler, for one build type, for a specific architecture. So any change of those settings will lead to a different binary. Okay, then you will see you're going, in fact, to have all the basically all the different steps, okay, from fetching out the source code, okay, to the build, and then to the packaging by copying all the headers, all the libraries into the right destination folders, and then basically the package info method. So there will be different methods invoked here in this build process. Okay, so now it's the right time to create basically my package. So for that, I'm going to, so I already have the version. I run the command new my package and my version, but I'm going to associate this, okay, with a package owner, and I will also determine the channel. Okay, so here, for example, I will just say, for example, I'm the owner, and it will be, the channel will be testing. Okay, I'm just going to do it like this. Okay, and what is yeah, sorry for that. Testing. Okay, so here I should have basically one package here. So I have my package. Okay, version 0.1. I can get more information about it. Can even just run a search. So I don't want to get all the details. Okay, so I can basically that according to my own platform, that package basically was built under 64-bit with GCC, with a certain version of GCC, and it was built on a Linux machine. But now let's try to do it differently, okay? Because all those settings were automatically provided, because here I'm on Linux machine and I have exactly those settings. But what if I would need, instead of using GCC, to use CLang, for example, or to build in 32 and 64-bit? Okay, so for that we have this concept of profile. And we have profiles, and we have so the default profile, okay, which is invoked by default, and we can see exactly the same settings, okay, but I can also create another profile if I want to compile with CLang. We'll set the right version, the default architecture, and so on. And now what I can do eventually is so quickly go back to my package. Okay, and now this time I'm going to create from the same recipe, okay, the exact same recipe, the same source code, and everything. I'm going, in fact, to build this time another library, okay, based on my CLang profile. CLang profile. CLang profile. Let me see. CLang. CLang profile. Okay. Okay. Let me put it a different way. CLang profile. Command search. Yeah, it's not a command search, but it's a command create. Sorry for that. Okay, let's create. Command search, command create. Yeah. CLang. Okay, so now we have command search and command search, and let's have a closer look at this library. Okay, and now we can see that for the same package, depending and relying on the same recipe, we have now two different package ID. Okay, so basically two different package binaries. One has been built with the GCC compiler, and the other one with Ceylon. So this one is under 64-bit architecture. But what if now I need to use basically the same profile, okay, but I'm going to build it under for 32-bit architecture. Okay. So again, now instead of two, I have now three different package binaries. Let's try to upload them into Artifactory. To upload. So yeah, to upload this one specifically, I want to upload everything that I have in my cache. And I'm going, in fact, yeah, to add all package binaries and to select my local repository, my Artifactory. Let's check now in our local repository, refresh. I have my package, and I have my different sub-packages, my different package binaries. And for each one of them, basically, you can get the Conan package info and more. Okay, if I basically drill down, I can see basically everything that I have within those packages. And I can see the compiler, the architecture, everything, in fact, all the settings that led to the creation of this sub-binary, of this package binary. So tomorrow, or if I now have another process, a third process, consuming basically this custom package, based on the settings that will be set on this environment, the right sub-package, the right package binary will be fetched and introduced into the build process. Okay, so this is exactly in that case that Conan, would be quite powerful, is quite powerful to dynamically manage, all those things based on the environment configuration, on the profiles that you will define. Let's now go back to the presentation. Okay, and it's now time to see some examples with CI/CD processes running with Jenkins Artifactory. Okay, so now that we have all those binaries in Artifactory, we can use it as a trusted source to provide all the build processes with the right dependencies and the right binaries. Conan here would be automatically get the right sub-binary. So here, for example, this one, or I would say, yeah, these are all the transitive dependencies, but here, for example, this one is a package. Only the right sub-package, only the right package binary will be retrieved based on the environment, based on what the client requested. Okay, so all those packages will be sent to my build system via a Conan install that will be, based on my Conan files. Okay, and with the right configuration that I have in my client, okay, and then I will be working either with CMake, Visual Studio, or some other build systems. Okay, Conan is fully agnostic. Then I will be building my binary packages that will be at the end of the day pushed to Artifactory and then reused by some other processes. So let's see in Jenkins. So in Jenkins, we have, for example, a demo. Okay, so from getting the source code to uploading the packages into Artifactory. So in terms of configuration, you first need to install the Jenkins plugin. The Artifactory plugin for Jenkins to define several objects, like the Artifactory server name, the Artifactory repo, the repo URL, and then just to define all the stages, okay, from pointing to the right repo to initiate your Conan client, to define what remote repository should be used. In that case, it's not directly Conan Center. It will be exactly like I've shown you before, the Conan local repository. And then I will be building my component. And once my component, my library is built, it will be just pushed to Artifactory via a Conan upload, okay, with the right tag. But it's not the end of the story, because here I'm going, in fact, to upload it as part with a bill of materials with the bar. Okay, so the idea is not only to upload individual files into a local repository, but it's to collect any information related to that build process and to have that information later on in my Artifactory itself. Okay, so we have very strong build management process here. Basically it's a system of record for my build processes. Okay, so here I can simply, if I want, record the environment variables, and I can see all the artifacts that were pushed, eventually all the dependencies prior to the build process. Okay, so here I can see that all those dependencies were used in particular, and if I want, I can see that this Conan package was produced by these two different builds. And at the same time, they were related to that build process. So there are different things, in fact, to manage the build reproducibility. Okay, so you can do it like this with profiles associated with your build agent, but you can also do it in a more dynamic way by pulling the right Docker image that will basically host, that will have the right Conan version, the right CMake, the right compiler with the right version, and so on. And basically, when you will run your Conan to create your package, everything will be basically, this Docker image will have the right profile and the right tools, the right libraries to perform your build the right way. So for that, you can rely eventually on this Docker registry on Docker Hub. So Luis Martinez de Bartolome is one of the Conan founder, and here basically you can use all those Docker images based on what version of compiler, GCC compiler you want to use. Will it be same for CLang and so on. So this is one of the approaches, okay, for build reproducibility, and the rest will be exactly the same. Okay, it's always about creating your package and then uploading it into Artifactory at the end. Another example in TFS, okay, and how basically to build your component and your packages across different platforms. So here, basically, you can have different builds, okay, that will be one by one building your component under different architecture, in release, in debug mode, and so on, okay, in order at the end to have all the package binaries that I described previously. So in terms of build definition, we have a plugin, okay, a current plugin that is available for TFS, where you can simply initialize your current config, log into Artifactory. So you just need, in fact, to provide the user to add. So here you can add the remote, okay, and then add the user. You will be creating the current package this way, specifying a profile, then creating your package, and this time by running the right Docker image. Okay, so it's mainly related to what we saw previously in Jenkins, and then at the end, basically running a command upload into Artifactory, with eventually also the build info that can be pushed. Okay, so I think there's with Conan, basically, you can do all that stuff in different build systems. But the main thing, in fact, to retain, okay, and to remember is that Conan again is build system agnostic. It's here, in fact, to manage and to handle all these dependency map to provide you with the right package on the right platform. And if the package is not available, so for example, you could have some packages that wouldn't be available on Conan Center. So you can completely configure. So at the time you run your build, if the Conan package is not available, eventually Conan will rebuild and will build, not rebuild, will build a package from source code. So there's also an option for that. So you won't get stuck. So yeah, that's pretty it. So again, don't forget to have a look at the, if you are not an Artifactory user, to have a look at the community edition of JFrog community edition for Conan. Very easy to find. JFrog community edition at Artifactory. Okay, and you can find basically this quite useful blog post that will then redirect you to this open source. So basically, we have an open source version for Java, for Maven, but here we have this community edition also for Conan. Okay, so don't hesitate to give it a try. Okay, and if you have any question, don't hesitate to reach out to us. And now it's So if you have we still have some minutes left.
Yeah. So guys, if you have any questions, feel free to write them in the Q&A box. Well, anyway, I think we will have to wrap it up because we're running out of time. So thank you, Hamza, for this presentation, and thank you all for joining us. We will be sending the recording with any other useful links in the next few days. And if you have any whatsoever questions, feel free to reach out to us and we'll be happy to help you. Thank you all again, and we hope to hear from you soon. Have a good day. Goodbye.
Bye, everyone.